Alright, so this is the first of probably many videos for the data visualization class. In this video, I'm going to be using a few of the data visualization tools that you can use in R. Specifically, I'm going to be doing scatter plots, comparison density plots, and horizontal bar graphs. So the first thing that we're going to do in order to do any of this is to actually import the data set into R. And that's what this command here does. So I specified the path where my data file lives. It's a CSV file, so I used the read.csv command in R. And essentially what I'm doing here is I'm pushing this path into this variable called test_data. And the reason I want to do that is I'm going to be referencing this data set quite a bit throughout my syntax, and to avoid having to constantly reference this path, I can just reference this variable, which is much shorter, and it still pulls from this data set. I've already imported my data set, so here we can see that there are 260 cases and 157 variables within this data set. So, great. Now we're going to move into the first data viz tool, which was creating a scatter plot. So in order to do that, first we're going to tell R what we want it to do. So we want it to create a plot. Now we're telling it where we want it to pull from. So we want it to pull from the data set test_data. And now we're telling it which variables we want it to pull. For my scatter plot, I was interested in looking at how POS and emotional exhaustion were related. So those were the variables I pulled here. POS underscore tote, EE underscore tote. So that's telling R where to pull, which variables to pull. Right here, main is telling R what I want to label my scatter plot. So I wanted to name it POS and EE, which is why I wrote that there. Here we move into naming the axes. So my x-axis is perceived organizational support, or POS, and the label for my y-axis was emotional exhaustion, EE. If you go back, you can see that it matches the order that my variables were listed in here, which makes a difference. You want to make sure that your scatter plot is pulling the correct data for the correct label. And then at the very end, this right here is telling R that I want my scatter plot to have equilateral triangles, because that's what my professor really wanted. If you don't like the equilateral triangles, then just delete it and it'll be fine. So now we actually run it. So I don't think you need to highlight it, but I like to highlight. And here we go. You have a scatter plot. So the next data viz tool that we're going to do is the comparison density plot. And in order to build this plot, you actually need to use the SM package, which I think stands for like smooth method or something like that. Now, I didn't include the line of syntax here, but prior to using the package, you actually need to install the package. And in order to do that, you just type in install.package, you include your parentheses, and then for this particular package, potentially all packages, I'm not sure, you include it in quotation marks. once you install your package, then you need to actually call it from your library, which is what this command is doing. So it's saying to essentially activate this package. Within this line, we're actually telling R kind of what the levels are of the variable, of the comparison variable for our comparison density plot. So if we move over here, we've got the data set that we're pulling from. D4 was the variable in my data set that I wanted to pull. It is employee location. It had 3 levels, which is why it says 1, 2, and 3 here. And then I provided the labels, or what each of those levels means. So 1 was Detroit, 2 is Houston, and 3 was Dallas. And within my data set, they actually say 1, 2, and 3. They don't say Detroit, Houston, and Dallas. So we're taking this information and we are pushing it into this office.f, and office.f is going to come into play in the next few lines. So on line 11, this is where we're actually telling R that we want it to do a comparison density plot. So we have our sm.density.compare. In parentheses, we've got what the data set is. Here we have the variable that it's actually going to be pulling to compare my levels on. And so I was interested in seeing what the level of POS looked like by office. So that's what I pulled right here. And then here I'm just referencing once again what my comparison variable is. Just like earlier, XLab is the label for the x-axis, and I labeled it Perceived Organizational Support Score. Title, as you might be able to guess, is the title of my density plot, so it was POS score by office. Line 13, call fill. From what I can tell, that's basically telling R that you do want your legend to have colors, and you can manipulate this to have different colors. I think I saw some that had like orange, different shades of green. I did not do that. So yeah, this right here is telling R that I want the levels within my legend to be office, and office, as we saw up here, had 3 levels: Detroit, Houston, and Dallas. So those density plots, the actual lines themselves, are going to be different colors, which is what's happening here. And then finally on line 14 we have the actual legend, and so you're able to actually see which colors correspond with which office. So we've got fill, call fill, so we want the legend to actually be color-coded. We want the levels within the legend to be the levels that we specified in the office factor. Locator, parentheses 1, from what I can tell, this was could be substituted with X and Y arguments, but I couldn't tell you much more beyond that. If you're really curious, you could do a lot of Googling to figure it out, but I kind of got stuck. So that's about the extent that I know about that line of syntax. So now we run it, and here we go. Now, as you can tell, there is still not a legend. So in order to actually get our legend, we just click, and voila, there it is. So you can see that this red line right here represents the Detroit office POS scores. This green line over here represents the Houston office scores, and then this blue line right here represents the Dallas scores. So now that we've done that, the last one that we're going to look at is creating a bar graph. So as we did up here, this first command is essentially telling R what we want it to do. So we want it to create a bar plot. We want it to pull the information from test_data. And this is the variable that it's going to pull from. So I was interested in seeing the breakdown by ethnicity in my data set, and that's what variable D3 is. Main, just like it was above, is the title of our bar graph. YLab and XLab are the Y and X axis labels respectively. So our Y axis label is ethnicity of employees, and X is the number of employees within each ethnicity. And if you wanted to do a horizontal bar graph, which my professor did want me to do that, you just add in this little line that says horiz equals true. So you're saying, yes, I do want for it to be horizontal. If you delete that, the default is for it to be vertical. So highlight, and we hit run, and there you go. When it was vertical, it still said Hispanic. I think when I realized it had to be horizontal and changed it, I think there might just not be enough room for that second ethnicity to pop up. So there you go. This is the video on doing a bunch of different data viz techniques within R.